Hello everyone, in this video we will explore the fascinating world of geometry. The information in this tutorial is perfect for students and math enthusiasts alike. Okay, so we are going to apply coordinate geometry, simultaneous equations, and also a certain circle theorem for us to answer the question which we have here at hand. Okay. So let me read the information regarding the question which you want to answer. The line y equals 3x minus 4 is a tangent to the circle whose center is the point 5 semicolon 2. Find the radius of the circle. So we want to find the length of the radius of the circle. Okay, so first of all, we want to sketch or to draw the line y equals 3x minus 4. And for us to do so, we must find the coordinates of the points where the line whose equation is y equals 3x minus 4 cuts the x-axis and the y-axis. So we need the coordinates of the points where this line whose equation is y equals 3x minus 4 meets the x-axis and the y-axis. So let me write the equation of our straight line. That's y equals 3x minus 4. So when this line crosses the y-axis here, the value of x will be 0. So when x equals 0, our y will be 3. And I'm going to substitute 0 for x here. So 3 multiplied by 0 minus 4, which is equal to 3 multiplied by 0 is 0 minus 4. So our y will be 0. So our line cuts the y-axis at the point 0 semicolon minus 4. So now we want to find the coordinates of the point where the line cuts the x-axis. So our line cuts the x-axis when y equals 0. Okay, so I'm going to substitute 0 for y in this equation. Okay, so here I'm going to, where there was y, I'm going to put 0. So 0 equals to 3x minus 4. And then I take this minus 4 to the left, so it becomes positive 4. So that will be 4 equals to 3x, and then divide both sides by the coefficient of x, which is 3. Finally, x equals to 4 over 3, which equals to 1 whole and a third. Okay, so the line crosses the x-axis at x equals 1 whole and a third, or at x equals 4 over 3. So the point where the line cuts the x-axis is written as 1 whole and a third for the x coordinate and 0 for the y coordinate. Okay, so the point 0 semicolon 4 is somewhere here. Okay, that's 0 semicolon minus 4, rather, not 4. Okay, and the point 1 whole and a third semicolon 0 is approximately somewhere here. Okay, that's 1 whole and a third semicolon 0. Okay, so that's our 2 points through which the line passes. So remember that the line whose equation is y equals 3x minus 4 is a tangent. So I'm going to join these 2 points until I touch the circle for me to draw the tangent whose equation is y equals 3x minus 4. Okay, so this is our tangent. Okay, till I touch the circle. Okay, remember we want to find the radius of the circle, so I'm going to draw my radius from the center to the circumference so that it meets the tangent which I've drawn. Okay, remember there is a theorem which says the angle between a tangent and the radius at the point of contact here is a right angle or 90 degrees. So you have got an angle of 90 degrees. Also remember to write the equation of the line on the line. That's y equals 3x minus 4. Okay, so we have drawn our tangent. So let's move on with our working. Now we want to find the gradient of this radius here. Okay, but for us to find the gradient of the radius, we must first of all find the gradient of this tangent, whose equation is y equals 3x minus 4. So we are going to use the property which states that the product of the gradients of the perpendicular lines equals 2 minus 1. Okay, so if we call the gradient of the tangent m1 and the gradient of the perpendicular radius m2, their product, which is m1 multiplied by m2, equals to -1. So we are going to use this fact or property to find the gradient of the radius after finding the gradient of the tangent. So I will show you how to find the gradient of the tangent using the equation of the tangent. First, I will write the standard equation for the equation of a straight line, which is y equals mx plus c. And then I'm going to write this equation of the tangent, which is y equals 3x minus 4, and compare these two. This m here stands for the gradient. So comparing this with this one, we can see that m in this equation is 3. So the gradient or m of the tangent is 3. Okay, so I'm going to use this product here to find the gradient of the radius, which is perpendicular to the tangent. Okay, so my m1 here is this one, 3. So I'm going to substitute 3 for m1. That's 3 multiplied by m2, which is the gradient of the tangent of the radius rather, equals -1. Then we divide both sides by 3 over 3. So finally, the gradient m2 of the radius equals to -1 over 3. So for us to find the radius or the length of the radius, first of all, we must find the equation of the radius and solve it simultaneously with the equation of the tangent. Okay, so for us to find the equation of the radius, we now have two important things here. We've got the coordinates of the point through which the radius passes, which is 5 semicolon 2, and also now we've got the gradient of the radius. So we are going to use y equals mx plus c for us to find the equation of the radius. Okay, so I'm going to substitute values in this equation. So since the radius passes through the point 5, 2, so my y here will be this 2, and my x here will be this 5, and m is -3. So this will help me to find c, which is the y-intercept, that's where the line cuts or meets the y-axis. Okay, this c. So substituting this 2 equals to m, that's -1/3, -1 over 3, multiplied by my x is 5 plus c. Okay, that's 2 equals to -5 over 3 plus c. Okay, if we simplify this, c equals to 2 plus 5 over 3, which is equal to 2 plus 1 and 2/3. That's our c is 3 wholes and 2/3. Okay, so finally the equation of the radius equals to y minus 1 over 3 x plus 3 wholes and 2 over 3. Okay, so let me simplify this further so that we remove the fractions. So it becomes y equals minus 1/3 x. I'm going to write this as a improper fraction. So 3 multiplied by 3, 9 plus 2, that's 11. So this one becomes 11 over 3. So since 3 is the lowest common multiple of our equation, I'm going to multiply by 3 throughout. So finally this one will be 3y equals to negative x plus 11. Okay, so I can write it as follows. That's 3y equals to 11 minus x. So this is the equation of the radius, which is perpendicular to the tangent, whose equation is y equals 3x minus 4. So for us to find the length of the radius, I must first of all find this point, the coordinates of this point of intersection of the radius and the tangent. So for me to find the coordinates of this point where the radius meets the tangent, I'm going to solve this equation 3y equals 11 minus x and y equals 3x minus 4 simultaneously, or as simultaneous equations. Okay, so the equation of the radius is 3y equals 11 minus x. So I'm going to solve these two simultaneously. Okay, so the first equation here is y equals 3x minus 4, and the second equation is 3y equals to 11 minus x. Okay, so there are many methods of solving simultaneous equations, but I'm going to use the substitution method. Okay, so the first equation says y equals 3x minus 4. So I'm going to substitute 3x minus 4 for y in the second equation. Okay, so where there is y, I'm going to put this 3x minus 4. So it becomes 3. So this second equation here, which I'm rewriting, in place of y, I'm going to put 3x minus 4 equals 11 minus x. And then here I remove the brackets. 3 multiplied by 3x, that's 9x. 3 multiplied by minus 4, that's minus 12, equals to 11 minus x. And then I collect like terms. 9x plus x equals to 11 plus 12, which is 10x, equals 23. And then I divide both sides by the coefficient of x, which is 10. And finally, our x equals to 2, 3. So the x coordinate of this point of intersection where the radius meets the tangent, the x coordinate is 2, 3. So now I want to find the y coordinate. Okay, so for me to find the y coordinate, I'm going to substitute 2, 3 for x in the equation y. This one, y equals 3x minus 4. Okay, so I'm substituting 2, 3 for x, so equals to y equals to 3 multiplied by 2, 3 minus 4, and it gives us 3 multiplied by 2, 3, that's 6, 9 minus 4. So finally, 6, 9 minus 4, you get 2, 9. So the y coordinate for this point here where the radius meets the tangent is 2,9. So finally our point of intersection is the x coordinate 2,3 semicolon, y coordinate 2,9. These are the coordinates of this point here. Okay, so remember we want to find the length of the radius, which is this one. So now our radius passes through 2 points. This one is the center 5 semicolon 2, and this one is the circumference, which is 2,3 semicolon 2,9. So now it's easy for us to find the length of this line or of the radius using the following formula. Okay, so if you want to find the length of a straight line, and in this case we want to find the length of the radius, if that line passes through 2 known points, you use the following formula. Okay, that's x2 minus x1 squared plus y2 minus y1 squared, or under a single square root. Okay, so now for us to find our radius, let's substitute values. So our x2, let us use this 5 here. So 5 minus our x1, we are going to use 2,3. Okay, minus 2,3 squared. Let me write the coordinates of this point: 2,3 semicolon 2,9. Okay, let me just make them clearer. That's 2,3 semicolon 2,9. Okay, so plus our y coordinate. So you must be consistent. I started taking this x coordinate, so I'm going to take also this y coordinate, which is 2 minus 2,9 squared under the single square root. So if you simplify if you work this using a calculator, you will get your radius is 2,84604 etc. Okay, so finally the length of the radius is 2,85 units to 3 significant figures. Okay, so that's the length of the radius. Okay, thank you for watching. See you in the next videos.